In this video, we're just going to practice using some of the techniques that we talked about in the previous video. So here's a solid revolution that comes from rotating this plane region around the x-axis, and it makes a cone like this one. And we know from the cone formula that the volume of the cone should be 250 pi divided by 3. So now we're going to do it using integration and make sure that we get the same thing. So let's do some u substitution. We have minus 1/2 x plus 5 du is equal to minus 1/2 dx minus 2 du equals dx. And this becomes minus 2 pi. And let's see what happens to the limits. When I plug in 0, I get 5. And when I plug in 10, I get 0. Okay, so I'll finish writing that. It's a little annoying though, because I'm gonna use that negative sign to flip the limits. But what do we have? We have u squared. Achoo, bless me, sorry. Du. So this is the same thing as 2 pi integrated from 0 to 5 u squared du, which is 2 pi times u cubed over 3 from 0 to 5, which is 2 pi times 125 over 3, which is equal to 250 pi over 3, which is what we knew the answer had to be from the cone formula. So this is a good way to make sure that you are doing a technique, correctly, when you can check and make sure you get the same answer when you do something two different ways. It's always fun. Okay, so how about we do, square root of x. So we'll just do the square root of x, looks like this. Here's y equals the square root of x. And how far should we go? Let's go up to 4. So let's say here is 4. And we rotate this thing around the x-axis. Okay. Then this is going to look kind of like a bullet, kind of like this. And a cross-section will just be a circle. And the radius of the cross-section will just be the square root of x. And so the area of a slice will be pi times square root of x squared, which is pi times x. And so this the volume of this solid is the integral from 0 to 4 pi times x dx, which is pi times x squared over 2 from 0 to 4. So what is this? 8 pi. Is that right? Better go more slowly. This is pi times 16 over 2, which is 8 pi. Okay. All right. So let's do something similar, but now instead of spinning it around the x-axis, let's spin it around the y-axis. And this will make a completely different shape. This will be a washer problem instead of a disk problem. So can you imagine what it's going to look like when, wish this eraser were bigger, when we spin it around the y-axis? It's going to look kind of like a bundt cake. It's going to be like this kind of shape. but it's going to be kind of hollow in the middle. You know, like this kind of thing. So it's going to be hollow. It doesn't exactly have a hole all the way through because of this point, but it almost has a hole all the way through. And if you take a cross section of this, it will be a washer like this. And where are the inner radius and the outer radius of the washer coming from? The washer has an inner radius and an outer radius. There's the inner one and there's the outer one. Okay. So the inner radius is coming from these lines. We're spinning this thing around the y-axis. So here's the inner radius r, and the outer radius is just this, capital R. You can see here that what is r going to be? Since we're going to have to figure this out by integrating along the y-axis, we need to switch from y as a function of x to x as a function of y. You can do that by squaring both sides, and y squared is equal to x. So that means that this little r is equal to y squared. And this big R is just 4 because this is 4. So the length of the big radius is constantly 4. Right? So now the answer to this problem is the integral from 0 to, I don't know. We have to integrate along the y-axis up to this point. So what is that? That's going to be the square root of 4 is 2. We'll integrate up to 2. And we have pi times the big radius squared, so that's pi times 16, minus pi times the little radius squared, which is y to the 4th. And all of this stuff is dy. Right. So what do we get? We get pi times 16y minus pi times y to the 5th over 5, evaluated from 0 to 2. And so the answer is 32 pi minus pi times 32 over 5. So 32 pi, 1 minus 1/5. So this is 4/5. What is 4 times 32? 128. 128 pi divided by 5. Okay, I'm going to blow my nose, sorry. So what else have we got? Should we do one more? No, let me stop the video for there. So we did 2 discs and 1 washer, and we did a washer along the y-axis. So you need to practice more of these, but these are just some examples.